Hi class, welcome to lesson 51 on pH and indicators. By the end of this lesson, you should be able to identify acids and bases based on pH values, calculate a pH relative to the hydronium ion concentration, and determine the relative acidity or basicity, also known as alkalinity, based on pH indicators from reference table M. For this lesson, you will definitely need to have reference table M. Make sure you're taking notes and let's get started. As a review, we know that the pH scale is a scale that shows acidity as any substance that has a pH of 7 or lower, and basicity as any substance that has a pH greater than 7. The pH of 7 is neutral, and as we deviate farther away from the 7, we will have stronger solutions. So the lower the pH, the more acidic, and the higher the pH, the more alkaline. By now, you should be able to identify acids and bases based on their pH value. This is review. Also, as a review, remember that any substance that has more hydronium ion than hydroxide ion is considered an acid. You can see from this chart here that solutions at all pHs have both hydronium or hydrogen ion and hydroxide. As we increase the pH, the amount of hydrogen or hydronium ion is decreasing. Not only do acidic solutions have a pH of less than 7, but they'll always have a greater concentration or molarity of hydrogen ions compared to hydroxide ions. At a neutral pH of 7, the concentration or molarity of hydrogen ions will always equal that to hydroxide ions. And here you can also see as we increase the alkalinity, we have pHs of greater than 7, we will have less hydronium ions than hydroxide ions. So pH actually stands for the power of the hydronium ion concentration or molarity. You can see as we change pH, the molarity of the hydrogen ion concentration changes. And if we look at the exponent on these molarities, that directly corresponds with the pH. But since all of these concentrations are less than 1, as the exponent becomes more and more negative, the actual number of hydrogen ion becomes smaller and smaller. So as a review, recall that every change in pH, so when we're talking about pH, we can see it here, is actually a 10-fold or a times 10 change in hydronium ion concentration. As we increase our pH, our hydronium ion concentration gets smaller. And this opposite is true as we decrease pH. So in this example, you can see that when we move from a pH of 6 to 3, the hydronium ion concentration is going to change 1,000-fold. So in order to see how much of a change there's going to be, just take the difference in pH and find the 10 to that power. So again, for instance, if I wanted to know how much more acidic the concentration of a pH of 2 is to a substance with a pH of 8, I see that the pH units are going to be 6 different. So the concentration is 10 to the power of 6, or actually 1 million times different. So a pH of 8 is 1,000,000 times less acidic than a pH of 2. This kind of explains why pH is such a big deal in biological processes, because a 1-fold in pH is actually a 10-fold change in concentration. By now, you should be able to calculate pH based on the relative change in hydronium ion concentration. Again, this is review.
When using pH indicators, we will use reference table M to determine the color the indicator will turn in various pHs. Of course, we remember that acids have pHs between 0 and 7, and bases have pHs from 7 to 14. The only perfectly neutral pH is a pH of exactly 7. On reference table M, we are given the pH range where the indicator is changing colors. So for methyl orange, the range is 3.2 to 4.4. The indicator is not very useful when it is changing colors, but it is very useful at pHs before and after the range. So if we add these numbers to our reference table, we'll see that a pH from 0 to 3.2, methyl orange will be the color to the left, or red, and a pH of 4.4 to 14, methyl orange will be the color to the right, or yellow. This is true for all the indicators. It is going to show the color to the left when the pH is between 0 and the first number, and the color to the right when the pH is between the second number and 14. So here you can see that bromothymol blue is going to be yellow at a pH of 0 to 6 and blue at a pH of 7.6 and higher. If we continue to apply this trend, we can see that phenolphthalein is going to be colorless at a pH of 0 to 8, and it will be pink at a pH of 9 to 14. And we can just continue to apply this trend to the other indicators. Now notice that not every indicator is good at distinguishing the difference between an acidic solution and a basic solution. But instead, indicators are great at determining how acidic a substance is or how basic. For instance, acids with a pH of 5 would be yellow in methyl orange, but so are bases. So we know that if we use 2 or more indicators, we can better isolate the exact color and the exact pH of a substance. For instance, if a substance turns Lipness red, we know its pH is going to be 4.5 or less, making it an acid. Now, if it also turns methyl orange red, we know it is a relatively strong acid. Versus a substance that turns red in Lipness and yellow in methyl orange will be a weak acid, because its pH will be closer to 7.
So what we know is that when we have a pH that is lower than the range found on reference table M, then the solution will have the color to the left. If you have a pH value greater than the range, then it will have the color to the right. So in this example, we see that a pH turns blue in Lipness. Is it acidic or basic? So when we look at Lipness, we can see that the blue color is on the right. So from the number on the right and above, so from a pH of 8.3 and higher, Lipness would be blue. We know that pHs of 8.3 and higher are basic. So when Lipness is blue, you have a base. In this next example, we have a solution that turns blue in bromothymol blue, but yellow in thymol blue. So we're looking for its pH range. So let's first find bromothymol blue. Bromothymol blue is blue at a pH of above 7.6. Thymol blue, which is different, is going to be yellow at a pH of below 8.0. So we know that our pH is greater than 7.6, but it is less than 8.0. By now, you should be able to determine the relative acidity or basicity based on pH indicators from reference table M. This marks the end of lesson number 51, acid and base indicators. Make sure you've taken good notes, write down any questions you have, and bring them to class. Complete your homework in Google Classroom, and make sure you have your reference table and calculator back in your backpack so you are prepared for class. I'll see you soon.